Okay, done. How many of you are done? Can you raise your hands? You please get out your own phone. Can you ask him? Please leave the class. Leave the class. Okay, so I think till now it's a fairly straightforward program. What the output will be? Is there any mistake, any syntax error or something you could see? It's a similar example as to what we were doing yesterday. So instead of making some new classes, we are just using a wrapper class here. So we have a custom class. All this custom class wants to do is take an object of some other class. So in this case, it is integer. We have a set function with which you can set its value, and it is a custom print function. So whatever it's going to print, it's going to be between some stars. So that's all. So it shows me an error is value. So I'm compiling it. So hmm, sorry, spelling mistake. Right. So this is what you get. Okay. Now what we want to do is assume that we want such a custom class for every kind of data. So right now you only have it for integer. Let's say you want one for double so that you can create a custom class for double, and whenever. So this is just a toy example here. We'll discuss what can be the real world implications of this. But let's say you have a custom class for double data type. So you can write one more class here. So probably you can change the name of this class to custom integer class, or let's say a custom I class. And then you can have a different class called custom D class. And if you look at it, the only change between the two classes will be in the data type. Everything else remains the same. So exactly the same thing that we were doing with methods. So this integer changes to double because now we want a custom double. This one changes to double. And I think that's all. Now the point is, how many custom classes will you write? So let's say you want a custom class for every class in your project, right? So there are 10 classes in your project, you write 10 custom classes. Now, the problem is, what if you were to add some classes tomorrow? You don't know what classes you will write tomorrow, but you also need a custom class for them. So there it's a problem. Tomorrow, if you have a class, you'll have to write a separate custom class for that. Right? So the person who comes up with the new class tomorrow, it becomes his or her responsibility to write a custom class for the class that he created. So what we can do instead of this, we can just make it a generic class, just like a method, which will work with any kind of object. So you can call it a custom generic class, or let's say a custom class. What you need to change is exactly the same thing. You declare this class to be generic by writing the type parameter here. And wherever you see the data type inside this class, something that changes in every class definition, you can just replace that by T. right? So you're going to say this I is going to be of type T. One thing that you should be careful about that is that this T, it cannot be a primitive data type. So you cannot use generics with primitive data types. It has to be a class and I is the object. Similarly, this integer changes to T. And yep, that's all. So let's see if it's working now. So when we run this code now, we get a few notes of unchecked and unsafe operations. If you want, you can ignore them for now. We'll discuss the problem that they can face later on. Generally, what is a better idea is, so there is one more thing that you do when you create a generic class, in addition to the generic methods, that is while creating this class, you tell it what is the type. So right now you haven't indicated what is the type. So this 10 goes in as an object. If you want it to be an integer, so you can just specify here that the custom class that I'm creating here is for an integer. And in the previous versions of Java, you would write the exact same thing here, but right now you need not write it because you have written it already once. So now what you are saying is I'm creating a custom class and this is for your integer data type. And if you compile this now, you no longer get any errors and you can run this, you get a 10. And now the point is you can create as many custom class objects as you want now with different data types. So your next one can be with double. And let's say you can put in a value 10.1. We need to change the object name. So let's make it D. That's all. So so if you run this, you see a double value. So the point is you can do it with every kind of class. It's not just integer or double. If it is some other class in your project, let's say a student, faculty, staff, library, book, anything, you can pass it here. And the same generic class is going to work with everything. Any question about this? That's all that's mostly there to a generic class. So it saves you from writing a lot of class definitions. Okay, so now my question to you is, which I want you to explore and try is, assume that, so it's again a toy example. We again want a custom class, but instead of just holding one data now, it wants to hold two data. So let's say sort of a pair. A relevant data structure is, you see, let's say something like a dictionary. Do you know dictionaries in Python? What are they? Key and value, right? And keys are supposed to be unique, but let's not worry about them that right now. So let's say you want to create a class dictionary. It's a Python dictionary. So what you are going to have there is maybe a key and a value, right? So instead of one type, I'm using two types here because key can be any type, value can be any type. It's totally up to you. Right, so this is generic because maybe your keys, they can be integers, your keys can be doubles, your keys can be strings, your keys can be student objects from your student class, your values can be anything. Maybe it is marks, maybe it's the price of a book, maybe it's the name of the book. So K and B, they can literally take any data type. So can you now modify this class definition and write it, this generic class definition? So all I want you to do is you should have two data members here, not just one. So one is going to be of type K, another is going to be of type V. K and V can be anything. And you should accordingly modify your set and print functions. So can you give it a go? The ideas and intuitions are exactly the same that we did in generic methods. So you just have to carefully see where to put K, where to put V. You should submit it in a written format. Write your names and roll number. So I want exactly how a dictionary works in Python. That just to store two different values of two different arrays, have a way to take their input and have a way to show them their things. If you want, you can name your class as imperfect dictionary. Just like we were taking one type function. Please get out. Okay, done. Right, so what do? There are two objects here, one of your class K, one of G, so let's call it J. X and Y. And instead of using this, so this is totally up to you. You can set I equals to X and J equals to Y, right? So that's how your set method changes, takes two values. And here you can print two lines instead of one. So in the first one, you can go about and print I. The second one, you can print if you want to change. That's all. And what changes here? You create, let's say, an object of your dictionary class. You need to give two values here. So this is your first one, which is integer. Maybe your second one is a string. Right? So you write both of these here. And now you can say C dot set 10 comma hello, right? Something like that. And you can print it. I think that if you want to try the different combination, you can say double and a string. And while setting it, do something like this. Sorry. New dictionary class names. So everything becomes. So yeah, let's check. Um, so you get this. Now, what's the use of this? So we have seen one is wrapper and other is sorry generic classes. So wrapper classes and generic classes. So now you see the idea here is if you start working with this way, so is there any project who are not using arrays? Can you raise your hand? Any project use arrays? Array list or some kind of list, a collection of objects. Any project who is not using that, and it's completely fine if your project is not using that. I'm just asking. Okay, how many of you are using arrays in your project? What about others? Are you using arrays or not? Or you don't know what's going on in your project? What classes are being used? Discuss with each other, discuss with your project partners or one or two people who have done most of the work and tell me. So this void here, it is the return type of this function, right? So don't get confused by this. Assume that k is integers. So your code becomes equivalent to this is integer, this is double. So there are two data members. One is integer, another is double. You are setting the value of these two data here. That's all. Right? This is a return type of this function. If you are returning anything and that is supposed to have a type, then you need to use k or b there also. You can do that. Then you need to do this dot I equals to I, this dot j equals to j. You can do that. Okay, so how many of you are using arrays? Reach to any conclusion? 1, 2, 3. Even if you are in the same project, you should raise your hands. 4, 5 solve, no arrays. Okay. So I encourage you to go back and look at your project code and see what kind of data structures are being used there. It's very highly likely that all of you are using arrays. If you are building any kind of system, it is you just can't do it without an array because you will need to store some kind of data in some format, and that is where data structures come in. Now, the idea is that we have discussed in the course so far were very raw kind of Java arrays, where you create an array, like there are 10, and then access all those elements with some indices. Right now, if you want here, with the help of this idea of generics, you can write your own custom array class. I'll just show you a small example. So you see, it's very much like, so let's say the team Num Java, they are working on building a NumPy equivalent in Java. So similarly, you can provide some classes to the Java users, which helps them to do the computings fast. So based on what we have discussed so far, we haven't discussed any strategy to maybe directly sort an array or swap two elements in the array or add all elements in the array. You need to implement that functionality on your own. If you were a Java developer, you might want to write a custom array class for the Java users so that all these functions are readily available. Right. So as an example, so you haven't, so as of now, let's say it's an integer array. So you can start with something like this, an array of integers, and then maybe let's say ARR, and then you can initialize this array in some constructor and then provide some functions to maybe sort this array, to search an element in this array, so on and so forth. But again, the point is, it might, you just don't need to do it for an integer array. There can be a double array, there can be an array of cats, there can be an array of students. And that's definitely something you are using in your project. In that case, it makes sense that you make this class generic. Generic means it's going to work with all kinds of arrays, and then you can implement all those functionalities. Now, the good news is all these kinds of classes, they already exist. And it's not just about array. Okay, anyone using maps in Java in their project? No? Stacks? Trees, binary trees, heaps. You use stacks, right? For what purpose? Okay, so as an example, you might be using a queue, right? Maybe let's say you have a student information system and you are catering to some requests, which takes time. Then you might want to maintain a queue of students and use NQ and DQ. So all kinds of data structures, they hold applications in all kind of projects. So the point is you can write a custom array class, a generic array class here, a generic stack, a generic queue. The point is you don't have to implement these from scratch on your own. And I'm pretty sure none of you have done that, right? So we are going to, have anyone done that on their own, apart from the team Num Java? Because that's what their project is. They are building everything from scratch. Okay. So talking about all these data structure classes, I hope you have a bit of idea about all these data structures. I don't want you to remember exact implementation or stuff, but the point is all these data structure classes, they are already there in Java and you can just pick them up and use them. And that framework, classes and interfaces, they are together called collection framework. Okay, so when we talk about this collection framework in Java, how many of you have an idea of what it is? Can you raise your hands? If it is something you have used in your project, you be having a little bit of idea about what it is. Okay, so we'll talk about what it is. So when you talk about collection framework, you'll actually see three different terms, which we will look at slowly. So one is actually something called a collection framework. Another is an entity called as collection, and another is an entity called collections. Now, all of these sound pretty similar, right? There's a word collection in them, but technically all of these are totally different. And that's like a very, very relevant Java interview question. So in case you are planning to write about your project in your resume, that is something you should know about. Like one of the most frequently asked questions. So let's see a bit about what all these are. So this diagram over here, this is something that you called collection framework. Can you take a look at it for 5 minutes and tell me what do you understand by it? It might look to be a slightly scary diagram, but are there few things that you can make out of it? So out of this, I think array list is something that you have used repeatedly. Okay, what all you have to say about it? Any observations? Anything that you can figure out from this type? Interface? Interfaces have same methods. Whatever. Okay, good point. Uh, so you have an interface collection, right? And the first point that Hridaya says is maybe collection, it defines certain methods since it's an interface, right? And whatever methods it defines, they should exist for all the classes which appear bottom in the hierarchy. A good point. So what kind of methods would you want? As the name suggests, collection means you can hold a lot of objects here. So there's a you can dump in a lot of objects here. That's a collection. And these are different examples of collection: arrays, lists, queues, vectors, etc., etc. So what kind of methods do you think are common that should exist across all the collections? Add. Okay, if you want to add an element to the pool or to the collection, okay, makes sense. Add. Come again. Update. Okay, maybe update at some random location. We need to talk about that. Should that exist in like each of these classes? Okay, modify or update. Maybe remove. Okay, that's one point, right? This collection interface here. So you see this entire thing is collection framework. This small part that you see over here, this interface is the collection interface. It's not going to define any of these methods for you, but it's going to impose a restriction that tomorrow you create a new class in bottom in this hierarchy, you should impose methods which are a part of collection interface. Okay, what else can you observe? Few relationships are there. So your solid line is the extends keyword and your dotted line is the implements keyword. So your iterable interface, we'll talk about it later. So right now we are focusing on the collect interface. And if you look at list, queue and set, these are three different kind of collections, but they are also interfaces. What does that mean? You cannot create an object of type collection. You cannot create an object of type list, but you can create an object of type array list. So you cannot say I'm creating a collection. That's like too generic. What do you mean by a collection? The same thing as we discussed before, right? You can't say I saw an animal. You should tell what animal did you see. You don't say I came to party in a vehicle. That's too generic. So you can create objects of array list, linked list, tree set, hash set, all of these data structures, and you can work with them. Okay, let's see one of these. And then we'll extend it further. So let's talk about array list. I is the one that you have worked with, some of you. So before that, let's look at what are the methods available in collection interface. So the best way is to go to the documentation and ask Java itself what it has to offer here. So we are right now talking about collection and not collections. These are two different things. Let us see what is collections. Wanted collection. Okay, so as you can see here, this collection here is an interface. And the moment you see this E in diamond operator here, you should understand that it's a generic interface. Instead of generic classes, you can also have generic interfaces. Generic interfaces also mean the same thing. Whatever data or whatever methods this interface is going to have, they are generic. They will work for any data type. Right? So if this E is integer, this interface will be working on integer data type. If so, instead of T, it's using the word E here. That's just a naming convention. If it is float, it will work on float data type, so on and so forth. So the entire collection framework is generic. So these are certain classes which are implementing it, and you can see maybe your array list here. And so we are not going to explore all of them, a few of them. So these are some other classes which are implementing this collection interface that can either be directly or indirectly, which are popularly used. So your set, list, map, etc. And so if you come down, you can look at certain methods. So if you look at all these methods, they are also generic. So there is an add method, right? As we discussed, so you should be able to add something to a collection, no matter what it is. It's going to take an object E, which is going to be of type E. So type E is generic here. You can add any kind of object in here. There is an add all method, clear method, contains. So there are a lot of methods here in this interface. So whichever other interface is implemented or whichever class is implemented, they should provide a functionality for this. So let's look at this array list class first. So this array list class comes here, right? So list implements collection and array list implements list. So what is happening here? Collection will have certain methods which all list queues and sets would have. Now list will add some specific methods on top of that, which might not be there for collection, but which should exist for array list and linked list. So this is a bit of an example here. So these are not all the functions, but few of the functions. So if you take a look at this, so if you look at the collection interface, it has functions like add an object, remove an object, what is the size of the collection, remove all elements in the collection, that is clear. So all of the interfaces which are implementing it and classes, they will have the implementation for these methods. Then if you come down to your list interface, right, list is also an interface. It's also defining certain methods. Now you see it has a method called getIntIndex. So if you provide an index, it will return you the element at that index in the collection frame, in your particular collection. Can you comment on why this method is not there in the collection? So this get method, it is not specified in the collection interface, but it is specified in the list interface. Right? Others might not use it. These are only lists that you access through indices. right? If you talk about sets, there are no indices in sets. So we'll talk about that. So these are certain methods which are specific to lists and you won't find them in the collection interface. And then there is a class array list which implements list. So it has all these methods which are in collection, which are in list, plus some more of its own. So as you move down in this collection hierarchy, your classes will start becoming more and more specific. There's really nothing conceptual to teach here. So the idea is to explore collection framework and see how you are going to create classes and objects here and use them. That we'll do in the next lab. So let's just pick one of these classes and try to use it. So let's say array list. So if you look at array list here, it's again a generic class. Everything here is generic. And one more thing, everything here is in java.utility package, right? So you need to import them. A few methods here. So you have a simple with array. So let's try with this simple one first. Let's get a new file.